Hey guys, I'm back with another one-dimensional kinematics problem, this time a really simple one on acceleration. Okay, so a sprinter accelerates from rest to 11.0 meters per second in 1.40 seconds. What is her acceleration A in meters per second squared and B in kilometers per hour squared? Okay, so the fact that the data in the question is given to you in meters per second and seconds means that, well, that's why they're asking you to find this value first, because it's going to give you the acceleration in meters per second squared automatically. Then we just have to convert to kilometers per hour squared. Okay, so let's get started. So for part A, first thing is to know the formula for acceleration. Now, if you understand the definition of acceleration, which is the change in velocity with respect to time, you'll remember the formula. Okay, so just writing down what I just said, acceleration is the change in velocity with respect to time. You already have the formula. Okay, so delta V is change in speed or change in velocity in this case. Okay, so that means V2 minus V1 over T2 minus T1. In this case, we're not given separate times. It's just a time interval, delta T, so we'll keep it as is. Okay, so V2, that's this right here. Okay, so if you don't recognize that as V2, well, this might help. It tells you the sprinter accelerates from rest. And this word is going to keep popping up for the rest of your physics life. Rest means V1 equals 0. Okay, so in this case, we don't always want to use V1 or V2. Sometimes we use V0. Okay, so in this example, I'll use 2 minus 1 just because that's what we're used to. Okay, so V2 is 11.0 meters per second. V1 is 0 meters per second. Divide that by the time interval 1.40 seconds and we get 7.86 meters per second squared. Okay, and just check, that is 3 sig figs, which is what we need because this number right here has 3 sig figs and this number right here has 3 sig figs. Okay, so therefore that number is accurate to the correct number of significant digits. All right, so that's part A. Now part B, we have to express this in kilometers per hour squared. Okay, now I know you guys already know what I'm about to say. That is, it is easy to convert between any unit and any other unit. Okay, you simply need to multiply by 1. Now, you might need to multiply by 1 twice, which is in fact the case in this example, but that's all you need to do. Okay, so let's take what we have. We have 7.86 meters per second squared, and I'm going to multiply that, like I said, by 1. Okay, except my 1 is going to be a fraction in brackets. Okay, so here's the catch. In this question, I'm trying to get rid of the meters to make it kilometers and the seconds squared to make it hours squared. So because I'm changing 2 different units, I need to multiply by 1 twice. Okay, so these 2 red brackets are going to be equivalent to 1. Why? Because like I said always before, if you multiply by any other number, you're going to change the question. And well, in this case, it's actually really beneficial to multiply by 1. The only catch is you have to pick a proper 1. Okay, so I'll show you how to do that. So first, let's get rid of the meters. We're trying to get kilometers as a distance measurement instead. Okay, so because I'm trying to get rid of meters, that means I have to put it in the denominator so that it gets divided out. Okay, because I'm trying to achieve the unit of kilometers, I'm going to write that on top. Then you ask yourself, what ratio of kilometers to meters equals 1? Okay, or what ratio of kilometers is equal to, well, meters? Okay, so it turns out 1 kilometer is 1,000 meters. There's the handy metric system for you guys once again. Okay, and next we're going to try to get rid of the second measurement because we want to get hours squared. Okay, so to get rid of seconds, I'm going to put seconds up here, and I want to get hours out. So I'm going to put hours on the bottom. Okay, so notice if I put an S here, it'll only cancel with one of the S's down here. So in fact, I need this to be squared. Okay, I'm not going to square it inside because that's just going to get a little bit too complicated. I'm going to square the outside. So just like in this part, ask yourself, what ratio of seconds to hours equals 1? Or how many seconds are there in an hour? Okay, so if you did your math, there's 60 seconds in a minute, 60 minutes in an hour. 60 times 60 is 3,600. So there are 3,600 seconds in 1 hour. Okay, so if you check this out, you're gonna have seconds squared. That's gonna cancel with your seconds squared there. Okay, leaving you with a unit of hours squared. And also your meters cancels out with the meters there, leaving you with kilometers. Okay, so the reason we can actually cancel out the seconds, because it's squared here, makes the squared also allows the 3,600 to get squared. Okay, so everything math-wise is still accurate. Okay, so remember that this isn't a whole number, but if you wanted to write it as a fraction, you could write it over 1. And whenever you multiply fractions, you multiply all the numerators together over all the denominators multiplied together. So 7.86 times 1 times 3,600 squared over 1 times 1,000 times 1. Okay, and if you multiply that whole number out, you're going to get 1.02 times 10 to the 5 kilometers per hour squared. Okay, so check, we've got 3 sig figs, so the number is accurate, plus we've got the right units, so we're done. Okay, so guys, that's it for this video. If you enjoyed it, if you learned something from it, please be sure to give that like button a click and subscribe to my channel so you can see previous physics videos, upcoming physics videos. Okay? And if you think someone else will benefit from watching this, please share it with them as well through Facebook or Twitter. Otherwise, it's been a pleasure. Guys, I will see you next time. Enjoy your day.